Welcome to lesson 151 of algebraic concepts, inverse variation. Here's our objective. Here's our vocabulary. Please pause the video and read these. They will help you understand what we're doing with the lesson. Some more vocabulary for you, some rules and notes, and basically a picture of an inverse variation. So the hyperbola is a graph of this function in this form, where x is in the denominator, or x times y if you cross multiply equals some constant. And then asymptotes are lines that the graph never crosses. They approach but never cross. They never touch. So let's look at some examples. So the athletic department purchased the machine, and it takes 1 mile to climb the speed. Now sets the climb speed to 6 miles per hour. How much time will it take them to climb 1 mile? So what do we do with all of that? All of those numbers. So basically, we know that distance equals speed times time from physics, from our physics class. So that's a basic thing. So what do we have? All right, so if we call x the speed and y is time, so we have the speed times the time equals 1 hour, which is 60. Okay, so now let's deal with it. Y equals 60 over x, and then we substitute the speed in for 6, because 60 minutes in a mile, and we get y equals 60 over 6, which equals 10. We get 10 minutes. So there we go. I know I did a crazy one on the first problem. Usually I say that for the third example, but I thought it'd be interesting to take a look at it. So just to talk about it. And let's see what we have next. Okay, so now let's graph the inverse variation. Y equals negative 18 over x to make it look like a thing. So I am going to graph this on my graphic calculator. So now that we have this, let me pull up the table first so you can see the points. So let's deal with the whole numbers on a graph. So at negative 6, when x is negative 6, y is 3. And at negative 3, we're at 6. Negative 2, we're at 9. Negative 1, we're at 18. At 0, it's an error, which means you can't divide by 0. 2 is at negative 9. 3 is at negative 6. And then 6 is at negative 3. Okay, so 2, 9. How are we going to do this? So we go by every threes. So let's say on x we're going 2, 4, 6, 8, 10, and by Y's, every 2 lines, maybe I got -3, 1, 2, 3, -6, 1, 2, 3, -9. Okay, so let's plot our points. So 2, -9, 3, -6, and 6 is -3. So our line is going something like this. So where the x-axis is an asymptote and the y-axis is an asymptote. So that is the graph. Also, what you will see pop up on a graph is something like this. So you should get 2 lines that look something like that. If you don't see this graph in your windows, you're going to have to adjust your windows so that you see it. All right, let's move on to the next problem. All right, let's look at our third example. Y varies inversely with x, and y equals 8 when x equals 9. So we know that x times y equals k. So they give us x is 9 and y is 8. And so then k equals 72. Okay, so now we found the constant of variation. Find x when y equals -3. So if y equals k over x, we found k was 72, x and y is -3. From a little cross multiplication, swapping the 3 and the x, we get x equals 72 over -3, and then x equals -24. So there you go. All right, those were our 3 examples. Please work on the practice problems and the upcoming slides on a separate piece of paper. And I will see you at the end of the video for a short recap. Okay, so there's a graph here. So use a table to graph x times y equals 12. And moving this around, 12 over x. And let's pull up a table of values from our calculator. All right, so we got 1 at 12, 2 is at 6, 3 is at 4, 4 is at 3, 6 is at 2, and 12 is at 1. All right, so I'm going to graph the other side, and I know one side, and I know the other side is a mirror. So at 1, you're at 12, which is off the chart because, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 1 is at 12. Let me erase that one. One is at 12, 2 is at 6. That's 2. It's my second dot. 3 is at 4. 4 is at 3. This is almost looking linear for these two dots. 6 is at 2. 5, 6 is at 1, 2. And 12 is at 1, which is off the chart. So we're coming through something like this. And if I know that the hyperbola makes a mirror image, I know my other one is going to look something like this. And this is what you should see on your calculator if you know how to hit it. So you hit this y equals button. It's in the top left corner of on your calculator. It's a gray button if you have a TI-84. So back in the welcome videos, I told you, get yourself a graphing calculator. You can get a TI-84 offline pretty cheaply. You'll see a screen come up with a bunch of Y's. What you're going to do, Y equals is already there. So all you got to do is do 12 divided by, and then hit the X, T, theta, N button, which is a black button that's next to the green alphabet. That will put in the X for you. You hit that and then hit graph, which is a gray button at the top in the top row. And you should see a graph of something that looks like that. Okay, same thing. Y equals 40 over X. All we gotta do is change the numbers. We graph it. All right, on the calculator, it looks something like this. And now I'm not gonna make a table of values. I'm gonna just use the calculator and show you what it looks like. But you can, if you don't have a calculator, use a table of values. Put a couple of numbers in. See what you come up with. 0, 1, 2, 3, and so on and so forth. And go down a couple, put a couple numbers in, see what you come up with. Okay, solve the equation. Y varies inversely with x, and y equals 1.2 and x equals 7. Okay, so x times y equals k. So 1.2 times 7 equals k. So say 4 carry the 1, that's 8.4 equals k. Then find y when x equals 0.5. And y equals 8.4 divided by 0.5, and y equals 16.8. I know that 0.5 is half, and I know if I double 8.4, I'll get 16.8. So all right, that brings us to the end of this lesson. Thank you for watching our inverse variation. I may have done an earlier video on inverse variation when I started linear functions, but this goes a little bit more in depth of how to solve these types of problems. So thank you for watching this video. This is one in a series of 5 or 6. And I hope you visit me on another video. Thanks for watching.